For this example, we're being asked to find the sum of the infinite geometric series 81, 9, 1, 1/9. So firstly, we need to remind ourselves of the formula. The sum to infinity is T1 on 1 minus R. And so we need T1, which in this case is 81. Oops. And we need R, which in this case is 1/9. And you can check that. 81 divided, beg your pardon, 9 divided by 81 is 1/9. The next one is 1 divided by 9, which is 1/9, and then 1/9 divided by 1, which is 1/9. So we can see that the R is 1/9. So our sum, our limiting sum or sum to infinity is going to be 81 divided by 1 minus 1/9, which is 81 divided by, now 1 minus 1/9 is 9/9 minus 1/9, which is 8/9. And so that's going to be 81 times 9/8, which is 729 on 8. It's an improper fraction, so we can either leave it at that or write it as a mixed number, which is 91 and 1/8. And that's it. For question B, all we're doing is using sigma notation. We do it exactly the same way, remembering that this is just another way of writing the sum to infinity. So sum to infinity is term 1 on 1 minus R. So looking at this little sequence here, this geometric sequence, our first term is going to be 4 on 5 to the power of 1, which is just 4 on 5. And our ratio is going to be 1 on 5. How did we do that? Well, have a look at the first few terms of the sequence. So we've got 4/5, and then our next one is going to be 4 on 5 squared, and that is actually 4/5 times 1/5. So there's our ratio of 1/5. And next one will be 4 on 5 cubed, which is going to be this previous term times 1/5. So 1/5 is our common ratio. So this is going to equal, using our formula, it's going to be 4/5 divided by 1 minus 1/5, which is 4/5 divided by, now 1 minus 1/5 is 5/5 minus 1/5, which is 4/5. 4/5 divided by 4/5 is simply 1, and that's it.